Let's see here. So let me begin with a word of prayer. So, here we go. Heavenly Father, we thank you for this time we have to meet together, and thank you for these students again. Thank you that you loved us, even though we didn't love you. And we thank you for your grace and mercy to us each day. And just pray that you be glorified in what we do this day, Lord. In your name I pray. Amen. All right, so quadratic equations. Let's get back into it. I remind you, a quadratic equation is, what does it look like? You are telling me the quadratic formula, which is fine, but the quadratic equation, right? Sort of the standard form of it is ax squared plus bx plus c equals to 0, right? And we derived last class that the solution can be given as follows: minus b plus or minus the square root of b squared minus 4ac divided by 2a, right? This is the, right here is the quadratic formula, right? Right, and the thing inside the square root is called the discriminant, right? And depending on whether that's positive, negative, or 0, we get different kinds of solutions, right? We can get real solutions, we can get complex solutions. Now, for a given problem, this may or may not be the right tool to use, right? Now, there's some problems in your book where it basically tells you, it says use the quadratic formula, right? And at least one of those problems is rather silly in terms of, like, I mean, if I had my druthers, I'd be like, well, I wouldn't use the quadratic formula on that one. But let's look at it. So x minus 2 times x minus 10 equals minus 16. The book tells us to use the quadratic formula to solve this. All right? So let's go through it. I'll follow the book's lead, even though I think it's foolish. All right? And so here we go. We got x squared minus 12x plus 20 equals to minus 16, multiplying it out. And then this gives me x squared minus 12x plus 36 equals to 0. Right? If I use the quadratic formula, I should identify what? A equals 1, B equals minus 12, C is 36. So the quadratic formula in this case is what? X equals to 12 plus or minus the square root of minus 12 quantity squared minus 4 times 1 times 36 divided by 2 times 1, which is just 2. What is 4 times 36 and what is 100? What is 12 squared? Well, we've got 12 plus or minus the square root of 144 minus 144. See, because 4 times 36 is 144. So the thing inside the square root is 0. So the formula here simplifies to just 12 over 2. The answer is 6. Right? Now, why did I say at the start of this, I think that the book has given us bad advice? There's easier ways to solve it. Can you guys tell me? How would you solve it if you weren't somebody to put a straitjacket around you and force you to use the quadratic formula? What would you do? I would factor this, right? This is just x minus 6 quantity squared. So x equals to 6 is the solution, right? All right. let's look at another example. Example 2. Suppose we're solving 0.13 x squared minus, oh, I don't know, 3.67x plus 10 equal to 0. These kind of problems come up in physics, for example, where you have real world numbers. You don't, I mean, only in math books do all the answers always end up being whole numbers, right? Because we don't want the students to all fail, right? I mean, like if we made the answers always ugly, it would be worse, right? You like for the answers to be whole numbers. That makes the math a little bit easier. We can focus on the math rather than the arithmetic sum. Anyway, this one, when I see something like this, I don't fight it. This is a quadratic formula problem. Right? I mean, to me, this just yells at me, use the quadratic formula. So here it goes. X equals to 3.67 plus or minus the square root of 3.67 quantity squared minus 4 times 0.13 times 10 divided by 2 times 0.13. So what's this going to give us? Aw, man. I thought I had water. Ah, I do have water. So I got to get my handy dandy calculator out to do this one for sure. Mm-hmm.
What's the 367 under the square root number?
Sure. But the reason I didn't do that is because we're squaring it. So like that minus gets eaten up in the square, right? But you're right. And I mean, this was minus a minus. That's why I put a plus there, right? Okay, so we've got 3.67 divided by, 2 times that is 0.26, yeah? I can do that much in my head. And then plus or minus the square root of this number, whatever it is, divided by 0.26. Let me calculate the number. Oh, man. All right. Marker's trying to get away from me. I cheated. I used my calculator. I'll explain more in a second here. Let me do the arithmetic here. 3.67, square it, minus 4 times 0.13 times 10. I get 8.2689. If I take the square root of that, I get 2.87, let's see here, so 3.67 divided by 0.26 plus or minus 2.876 divided by 0.26. All right, what is that? Yeah.
Can you start off the equation by just multiplying everything by 100?
You could. You could do that. Indeed. So I get 14.12 plus or minus 11.06, which works out to 25.18 or 3.056, roughly. Now, what I did to get those numbers, if you're watching me, you saw that I wrote the numbers down before I did all the other arithmetic, right? And the reason for that is this Casio 115EX has a quadratic solver built into it. If you go to like mode and you go to equation, it comes up to a screen where you can pick equation solver and you can just put the coefficients a, b, c in and it will tell you the answers. There's two of them. They could be real. It even does complex case. All right. So this has the quadratic formula built into it. I don't think the TI-30 does. You do need to use a scientific calculator. That's why I encourage students to use this one in part, because I think that's a nice feature. But anyway, this is, you're like, well, you mean you can find the answers with a calculator? That doesn't seem fair. Well, it's not as good as it sounds, because I do expect you to show your work, right? So like, even if it's just a quadratic formula problem, I do expect you to write down this, and you know, even if you know the numbers it works out to, you still have to write it down. But I do think we can all agree that using the quadratic formula does come with a certain, you know, there's a certain burden of calculation here, isn't there? Like, it does take some lifting to actually execute these formulas and like work them out correctly. There's a lot of steps. And if you're not really good with your calculator, it's really easy to get this wrong. So I do not, generically speaking, encourage use of the quadratic formula as that's not my first line of defense for solving a quadratic equation. Let's look at another one here. Example 3. What if I had x squared plus 10, well, let's see, to x squared plus, well, yeah, fine, 10x plus, oh, I don't know, 42. All right. So this one here, I'm going to use completing the square to solve this one, all right? I'm going to use completing the square and the square root property. That's the method I'm going to use. Completing square and square root property. That's the path I'm going to go down here, okay? Here we go. So complete the square. This is x plus quantity 5 squared. So I took half of the 10. Half of 10 is 5, right? And I heard minus 25. Very good. Minus 25 plus 42, right? The 42 is still there. This is all equal to 0, right? Then I isolate the square. This gives me x plus 5 squared equals to, let's see, 45. Let's see, what's 42 minus 25 is what? 17. So if I move that to the other side, I get a minus 17, yeah? Now I use the square root property. We get x plus 5 equals to plus or minus the square root of minus 17. Remember, we can rewrite the square root of minus 17 as plus or minus I times the square root of 17. So what's the answer? Solve for x, right? X equals to minus 5 plus or minus I root 17. Now, sometimes problems come, you know, they have an easier format, right? Like, how about this? What if you've come up against this problem? 2x minus 3 times 3x plus 4 equals to 0. You want to solve it. This is kind of a silly problem, right? Because it's already factored. How would you solve this one? What's that? Set both of them equal to 0. What's that? Oh, yeah. Sorry. Can you see from there? Okay, cool. somebody missing. They had car trouble today. I forget if it was your section or the next section, though, but somebody's missing. So I try to make sure we get everything. Anyway, so 2x minus 3. So I heard 2x minus 3 equal to 0, right? Or 3x plus 4 equals to 0. So you solve those. You either get x is equal to 3 halves, or x is equal to minus 4/3, right? So this kind of problem, it would be exceedingly silly to multiply this out and then to use the quadratic formula, right? That would be like a lot of effort when you could just use the basic factoring idea to solve this one. It would be much, much smarter, right? Here's another one. What if I have 2x minus 3 quantity squared equals to, oh, I don't know, 7. You want to solve that problem. Again, you don't want to use the quadratic formula. You don't want to, I mean, you just want to use the square root property, right? So if we take the square root of both sides, what do we get? Square root property tells me I've got 2x minus 3 equals to plus or minus the square root of 7, which gives me 2x is equal to 3 plus or minus root 7. Now I just need to divide by 2, right? Divide by 2, we get x is equal to 3 plus or minus root 7 over 2, and there you go. Them's your answers. All right, let me do one more completing the square here, and then we'll move on. Suppose we've got something like 6x squared plus 5x minus, oh, I don't know, 3 equals to 0. I'm pretty sure this doesn't factor. All right, I'm not even going to try. What I'm going to try to do here is complete the square. And so what I want to do is first divide by 6. What's 3 over 6? 1/2, yeah. All right. So I divided by 6. Now I complete the square. So I want to take half. What is half of 5/6? Five twelfths. Very good. So x plus 5/12 squared, right? Now I have to subtract 5/12 squared. What is that? What is 5/12 squared? I'll write it up here. It is 25 over 144. Right? So I do minus 25 over 144 minus 1/2 equals 0. I'm gonna use the square root property. I'm gonna solve by using the square root property again here because it's nice. So this gives me x plus 5 over 12 quantity squared equals to 25 over 144 plus 1/2, right? Can you guys simplify that for me? What's 25 plus 144? 25 over 144 plus 1/2. Well, 1/2 is what? It's 72 over 144, right? So 72 plus 25 is 97? I think we get 97 over 144 if I didn't make a mistake. You guys would tell me if I made a mistake, right?
You're good.
I'm good. Okay, good. And now we take the square root of both sides, and we get x plus 5 over 12 equals to plus or minus the square root of 97 over 144. But that we can simplify a little bit. That's plus or minus the square root of 97 divided by the square root of 144, which is what? What's the square root of 144? Well, it's just 12. And then finally, the finishing blow, solve for x. X equals, minus 5 plus or minus the square root of 97 divided by 12. There you go. Now, this problem, it's kind of on the bubble for me. Like, is this the right approach? Or is the quadratic formula the right approach? All right. I mean, you could go either way here, I think. I'm completing the square partly because you guys need to see more completing the square. Right? You need to work completing the square problems until you're comfortable with it. Right? So you should keep trying completing the square until you're bored. Once you're totally bored of completing, wait, that's not good. You might be bored to start with. Work completing the square until like you feel like you could explain it to your grandma. You're like, my grandma's dead. Well, this was not foreseen. So you can find a person you can explain it to, you know. Someone annoying who won't listen to you. If you can explain it to them, then you're where you need to be. Let's see here. Any questions about quadratic equations? Let us look at some applications of quadratic formulas. Okay, so where was I? Oh, back over here. So to recap, when we're solving a quadratic equation, strategy number one: if you can factor it, great, do that. That's the easiest way to solve, right? If it's just factors, wonderful, you can just solve, right? If that doesn't work, it may be that completing the square and the square root property is a good method, right? If that still doesn't look like a good path, then you can fall back on the quadratic formula, right? But we can always solve a quadratic equation. There's no quadratic equation that you can write down that you can't solve. Like, we have the formula. It always can be solved. All right? It's just a matter of doing it. So here's an example problem. Example 7. Find consecutive integers whose product is, let's try 42. Somebody here can just answer this question without doing algebra, right? Can you tell me the answer? What is it? I heard 6 and 7. Very good. Let's see how algebra tells that and see if it offers any surprises. So if the one integer is x, what's the next integer? If I have x is 5, what's 6? It's x plus 1. So I want x times x plus 1 equal to 42, right? How do I solve that? Well, this is x squared plus x minus 42 equals to 0. As I was just saying, if we can factor it, then factor it, you know? So this is x plus 7 times x minus 6 equal to 0. So what are my solutions? My solutions are x equal minus 7, right? And also x equals plus 6, right? Now, those are not the consecutive integers, right? Those are the different numbers which, if you add 1 to, x plus 1 is what? Minus 6, right? X plus 1 here is 7. So there are two answers. Minus 7 and then minus 6, or 6 and then 7. So most people, when they're asked this question, anybody can come up with these, right? But a lot of you, did anybody think of these in here? When I asked the consecutive integers that's product is 42, did anybody think, oh, minus 7 and minus 6? No, most people don't, right? But the algebra will reveal it. So that's why there's two answers, okay? Now, part of that might just be that you don't know what an integer means, right? Remember, integers are whole numbers and their negatives, right? So 0, plus or minus 1, plus or minus 2, plus or minus 3, these are integers. Let me do a twist on this problem. Are there integers, right, whose product, are there successive integers whose product is, oh, I don't know, 22, right? Do there exist consecutive integers whose product is 22? What do you think? Yes, no, maybe so? Well, let's not think too hard about it. Let's let algebra do the thinking for us, yeah? So we got to solve x times x plus 1 equals to 22. What happens if we do that? We've got x squared plus x minus 22 equal to 0. And I'm going to let the quadratic formula do the lifting here. So x equals to minus 1 plus or minus the square root of 1 minus 4 times 1 times minus 22 divided by 2. Right? In other words, x is equal to minus 1 plus or minus the square root of 85 over 2. Now you might be wondering what exactly are those numbers. I mean, I can figure it out in a second here. Give me a second. I'll give it to you. I'll get you the digits. We got 1A, 1B, minus 22 is my C. So these numerically, the decimal form of this, something like 4.21 and minus 5.21. Are those integers? They're not. They're not whole numbers, right? So the answer to this question is no, there don't exist consecutive integers whose product is 22. You can't do it. Because the numbers we'd like to do it are not integers, right? So I won't have class time to do all of the different examples that are in your homework, but I hope I do enough here that you can kind of put the pieces together and do the ones that are in there. I think you'll get it. Let's see here. Let's try another one here. Example 9. We've got a barn, all right? And the wall of the barn, so this is a barn wall. You have 252 square feet in this wall, all right? And you're told that the length is 10 feet longer than twice its width. Length is 10 feet longer than twice the width. All right, so if I say this is the length, right, and this is the width, right, what equation can we write from that sentence at the top of the board? The length is 10 feet longer than twice the width. So L is equal to twice the width, right, plus 10. What's the area equal to? Length times width, right? But the length is 2W plus 10, right? And what's that all equal to? Well, we're told it's 252 square feet, right? So we set this equal to 252. Lo and behold, like all the applications problems in section, what is it? I've lost track of which section. 1.5, section 1.5. These are all, you know, there's some story time, but after the story time is done, it's a quadratic formula that you either have to set up or solve. Okay, so how do you solve that? Let's multiply it out, right? So we've got 2w squared plus 10w minus 252 equals to 0. Any suggestions? I think I'd like to divide by 2, right? Just to make it a little bit easier to do the arithmetic. W squared plus 5w minus 126, isn't it? Can you guys factor that? Let's think about 126. 126 is what? It's 2 times 63? Isn't that right? And 63 is 7 times 9, right? Oh, look at that. 18, well, no. Oh, how 14? What's 14 minus 9? That's 5. So we should use a 14 and a 9. Plus 14? Minus 9, maybe? Woohoo, we factored it. Now, if you're like me and the other time I taught, I have an unfair advantage. I worked this problem before. I know these numbers, and I also have the answer here. But, you know, if I just look at this and I forget I have those resources, I may or may not see this factorization, honestly. And I have, I'm pretty sure I have a better number sense than most of you, right? I'm from a time before calculators for the most part. I like numbers. I enjoy arithmetic. I'm weird like that. So you might not see this, right? Now, if you fiddle around with the factors of 126, you're more likely to see it. But what's the other method you could use to solve this? You could just fall back on the quadratic formula, right? For this one if you get stuck. So it's there. All right, anyway, let's move along here. So the answers are either w equals to minus 14 or w equals to 9. Now, can the width be minus 14 feet? No, so that is extraneous. That is an extraneous solution right there. And then how about w? 9 is fine though, right? So what's the length? Remember, it's 2w plus 10, which in this case is 2 times 9 plus 10, which is what, 28. So we have, the answer is L equals to 28 feet, and the width is 9 foot. That's the dimensions on the barn wall that we're looking for. Is good? I hope. All right, let's do another one. So this one requires a little bit more thinking, but I'll walk you through it, okay? So what I'm working right now is more or less 29 in your homework. All right, so it looks something like this. You've got this room, all right? And you're told that this is 27 feet, and this is given to be 21 feet. All right? And then you're putting in a carpet in the middle, all right, that has an area. The deal is you've got enough money to buy a carpet that has 187 square feet. All right, this is expensive carpet. You want to buy as much as you can to make the room beautiful, but you can only buy 187 square feet for some reason. Or I don't know, maybe that's the amount they've got left. You make up whatever kind of backstory you want. Now here's the deal. We want a uniform strip surrounding it. Okay? The question then is, what are the dimensions of the carpet? What are the dimensions of the carpet given this scenario? So when I'm faced with a problem like this, I have to ask the question is, what are the dimensions of the carpet, right? That's the goal. What are the dimensions of the carpet? But, so dimension, of course, are length and width, right? But probably just thinking directly about length and width is a bad choice here, right? The real question, you want to trade the thing you're asked about for something that's easier to think about, which in this case is the width of the strip. Right? So let's call the width of the strip x. Right? It's a uniform strip, so there's x there, but there's also x over here. If I obviously my picture is not quite right, but the picture is just a mnemonic. It's a guide, right? So, all right. If this is the, which is the length and which is the width, I guess I'm putting an L up here. I mean, it's always debatable which is the L and which is the W, right? But what is L equal to here? This distance right here. You can see it up here maybe, right? Look up here. So this distance is x, right? This distance is x. So what's left over in the middle? I heard a 27 minus 2x. I like that. That's it. And if you understand that, then you won't be surprised when I tell you that the width, right? The width should be what? 21 minus 2x again, yeah. Aha, so now we know the length, we know the width, we know the area. We can write down an equation. Area is length times width, right? So 187 is equal to the length times the width, which in this case is 27 minus 2x times 21 minus 2x. Ah, a quadratic formula. We can do this, yeah? So let us do it. We got 187. 27 times 21 happens to be 567. And then you got yourself a minus 42x and a minus 54x. And you got yourself a plus 4x squared there. I'll clean that up over here. This leads me to 4x squared minus 96x plus 380 equals to 0. At this point, you can just chuck those numbers into the quadratic formula if you want. I think it's worth our effort to divide by 4. That makes the arithmetic easier here. If I divide by 4, what happens? I get x squared minus 24x plus 95. 380 divided by 4 is 95. Can you factor that? What is 95? 95 is 5 times 19, right? Are 5 and 19 related to 24? Ooh, add them. So we need minus and minus, yeah? So we've got, this factors to x minus 5 times x minus 19 equals to 0. Again, if you don't see the factoring, do not despair. You have the quadratic formula. Right? So what are the answers? For x, at least, these are answers, right? This is a step towards the answer. So we either have x equals to 5 or x equals to 19. Right? So if x equals to 5, then the length was what? 27 minus 2x. The width was 21 minus 2x. So you're looking at 17 or 11. So the answer is 11 feet by 17 feet. Those are the dimensions to the carpet. If the answer is 5. What if the answer was 19? What if x was 19? It can't be. Why? It'd be negative? What would be negative? The answer, the L's? The L or the W would be negative? Hey, that's a good way to look at it. Absolutely, good answer, good answer. Another way to see it is if x were 19, just think about the picture, right? You can't cut off 19 from down here and 19 from up here. That would give you 38 feet worth of strip, but there's only 21 feet to use here. You can't have a 19-foot strip above and below a carpet where there's only 21 feet total to work with. But very good. If you plug the other number into L and W, you get negative numbers, which are not distances. Another very good answer. Anyway, we have to throw out, just like we threw out 14 in the previous problem, this one, we have to throw out 19. This is extraneous. It's not in the solution set for physical reasons. All right? Okay. So let's start. You know, on the one hand, I'm happy I'm selling my house. But on the other hand, I'm sad that I can't be here Friday to teach you guys the next section. I mean, I will post the video, right? But let me just at least get into it and do an example or two. Let me show you where we're going. So the next section is other equations, roughly speaking. So in particular, let me just give you a sample. We'll solve things like x over 3x minus 1 equal to 2x over x plus 2. Something like that. We might solve that equation. We might solve something like the square root of x minus 2 equal to the square root of x plus 1. We could solve that one. We might solve something like 3x plus 7 to the 1/3 power equals to 2, right? So equations like this and more, we will talk about how to solve for Friday. And by talk about, I mean I'm going to give you a video from tomorrow morning when I work a bunch of them for that section, okay? But since we're here, we have 5 minutes, I think. Let you guys pick which kind of one of these do you want to do right now? We can do at least one of them right now. The second one? You picked the hard one. All right, now I'm not going to do that one because I just made it up, which means there's no telling what kind of badness is waiting for me there. I just made it up. So I will look for one in your homework. I will work that one. So this is kind of the same sort of thing. Where are you? Example 11. Here we're facing x minus the square root of 15 minus 2x, all right, equals to 0. So basically, the last 10 problems in your homework are things like this, okay? Problems 1 through 29 are quadratic equations and applications of quadratic equations. There's only 40 problems in the week 2 homework compared to the 50 in week 1, right? Okay, so what do we do? There's violence in the streets. What should you do? No, you should isolate the radicals. You have to isolate the radicals. So x equals to the square root of 15 minus 2x. Sorry, that joke is starting to get a little bit too real. So then to get rid of the radicals, you just square them, make them into squares, you know. That would have worked better about 40 years ago. See, I could explain it to you. A square is a person who's part of the establishment. Like, you're a square, man. You know, like you're not one of the hippies, you're a square. No? All right, well, I tried. 15, oh, look at this. What is this? Ah, our old nemesis, the quadratic equation. X squared plus 2x minus 15 equal to 0. 15 is 3 times 5, and 5 minus 3 is 2. So I think this one we can factor. I'm going to say plus 5. I'm going to say minus 3. Right? So our answers, x equals to minus 5, or x equals to 3. So are these answers? I mean, they're answers to the quadratic formula. Are they quadratic? Are they actually answers to the original problem? You have to check them. All right? Check them. Plug them back in. See if they work. Do they? So plug it back in here is minus 5 minus the square root of 15 minus 2 times minus 5. What's that equal to? That's minus 5. This is the square root of 25, which is 5. So that's minus 10. Is that equal to 0? It is not, right? So when you plug minus 5 back in, it does not work. In contrast, if we plug 3 in, we get 3 minus 3, which is 0. Hooray! So 3 is an answer, minus 5 is not. Minus 5 is what's called an extraneous solution. At some point in this course, I always tell my students that if I was to be a rapper, I would be called Extraneous G. My tagline would be, I'm not even in the solution set. So anyway, there you go. I feel like I delivered it as well as it can be delivered. Good day to you.
Thank you.
Yeah.